We're asked to, we're given 2 points. It's this problem. We're given 2 points. We're asked to find the equation of the line. And I can move on. We can move on after that to page 45.
Could we do number 49 then?
Say it again.
Number 49.
So you wanted to do this and also 49. Yes?
Yeah.
Excellent. Very good. Good idea. I'm going to write it here so I don't forget. Okay, so let's finish up. What do I have to find first? Excellent. Very good. Label them x1, y1 if you have any difficulty so you don't forget the correct order or you don't make a mistake for whatever other reason possible. So y2 minus y1, negative 4 minus negative 3 over negative 1 minus 2. So that will be our slope. So negative 4 plus 3 is negative 1. Negative 1 minus 2 is negative 3. Two negative numbers, when I divide them, we will obtain a positive number. Since we do not have the y-intercept, we do not have 0 comma a number, we will definitely look at y minus y1 equals the slope times x minus x1.
We use the point slope form.
The point slope form, exactly. So let's do just that. So y minus y1 equals the slope times x minus x1. It doesn't matter which point you want to use. I would like to use the first one with 2 and negative 3 and 1/3 as the slope. I perform all the operations I can, so this is y plus 3 equals 1/3 x minus 2. I distribute 1/3 minus 2/3, and then I bring negative 3 to the other side. So when I bring negative 3 to the other side, obviously I have to find the least common denominator, which is 3. So then this is 1/3 x minus, both are negative, so this one needs a 3 because it's over 1. So I have 2 plus 9. Both are negative. I have to add them. So 2 plus 9 would be 11. So y equals 1/3 x minus 11 over 3. This is the equation of the line passing through the given points. And I know you selected 49, but let me ask you if you have any questions before we look at 49. And I'm going to copy the points. Any questions on, which number was that on 40? No, it wasn't. Was it 40? Yes, it was 40. Any questions on 40, please? Anyone?
No.
Perfect. Moving on then. Same thing, same question. We are given 2 ordered pairs. We have to find the slope. y2 minus y1. Over x2 minus x1. This is so much easier than adding those fractions. Thank you for choosing this. 2h over h, 2. Quite nice. Thank you. So we found the slope. So now we are going to use the point slope form. Y minus y1 equals the slope times x minus x1, where the slope is 2. I'm going to choose, obviously, the first point with x and 2x plus 3. Remember, there is a minus that has to be distributed. So y minus 2x minus 3 equals 2, but x minus x is 0. So then y equals 2x plus 3. Very good pick. Any questions, anyone? Okay, so I'd like to continue with, actually I was looking at 3 different word problems. You can select something else if you'd like. 66, 72, 77. So we have to talk about the profit and loss analysis, straight line depreciation. And here's another potentially interesting problem for you, for us, organic food sales. Are we okay with that? Everyone on board? Okay, I'm assuming someone is paying attention. So let's take a look at 66. So 66. If you'd like to move on to page 45, I forgot to say, sorry. And let's read the question. Profit and loss analysis. I think it's Boxowitz. Okay, fine, incorporated. A computer firm is planning to sell a new graphing calculator. Nice. For the first year, the fixed costs for setting up the new production line are $100,000. Take notes. Fixed costs, $100,000. Okay, the variable costs for each calculator are 20. Variable costs, they depend on the number of units, so they will be 20 times the number of units we manufacture and sell. Units manufactured and sold. We hope. The sales department projects that 150,000 calculators will be sold during the first year at a price of, so the revenue will be 45 each, so 45 times X. So this is fixed cost, variable costs, revenue. And they say that the first year they predict to sell 150,000 sales. Perfect. I took all my notes so far, reading the problem. I write down what I think is important. And now the first question, part A. In part A, it says, find and graph C of X. C of X is the total cost function. Of producing X calculators. So we know that the total cost is always the variable cost of X plus the fixed cost or fixed costs. We have both. So this one is 20x and this one is 100,000. I'm just going to replace them, and that is the total cost function. $20x plus 100,000. Okay. It also says to graph it. So I'm just looking to see, they were asking us to also graph the revenue and the profit, so we're going to graph all of them at the same time. In part B, So we'll come back to the graphs. In part B, it says, using the same axis as in part A, okay, find and graph R of X, the total revenue. So we already have R of X. I'm going to write it one more time. So this is 45X. Part C. Using the same axis, yes, find and graph P of X. So P of X is the profit for manufacturing X and selling them. And the profit is always the revenue of X minus the total costs. So they're asking us to find the profit. So P of X, I copy the revenue, which is 45X, and I subtract distributing because I have to subtract the variable and I have to subtract the fixed. Minus 20X and minus 100,000. Combining like terms, we get 45 minus 20, which is 25, and minus 100,000. Okay, so in part D, what profit or loss will the firm realize if the expected sales such and such? So now let's read, because we have all three functions, let's graph them on the same coordinate system, and then we move on to the other D and E parts. Okay, so we have to graph C of X, 20X plus 100,000. So when X is 0, C is 100,000. If I set this equal to 0, I will get a negative X. I cannot manufacture negative 1,500 calculators. So I know that I'm not going to look at the second quadrant, third quadrant, or fourth quadrant. So we're going to look at the first quadrant only. So here I will have the total cost, I will also have the revenue, and I will also have the profit. And here the number of units. So of course I'm going to use 3 different colors. So we have to plan ahead. So when X is 0, C is 100,000. So we'll see how much what we want to use as the unit. Now for the revenue, when X is 0, we have 0. So the revenue starts at the origin. And let's say at 1,000 will be 45,000. I just am trying to see how high we go here on the y-axis. So for revenue, when X is 0, the revenue is 0. When X is, let's say, 100,000, that would be 45 and 5 zeros. So that would be 4 million. I don't have to go that high. I can just, although we do have 150,000 calculators. Okay, so let's see what happens with the profit for a second. So the profit is 25x minus 100,000. When X is 0, I don't need that. It's negative 100,000. That's not possible. Let's see when X is 150,000. What do we get? I'm grabbing my calculator. So we have to answer that question anyway, times 150,000. And then minus 100,000. So it's 3.6 million. Okay, so obviously, and let's see the revenue with 45 times 150,000. Oh, that's too many zeros. Yep. Okay, I should not exceed 7 million. Okay then, so I have an idea now. Okay, so 20, 40, 60, 80, 100,000 units. 20, 40, 60. So I have here, this one is 150,000. Okay. So I don't want to exceed 7 million on the y-axis. Fine. So C is 100,000. going to be very small. Okay, so I'm going to say 1, 2, 3, 4, 5, 6, 7 million. 1, 2, 3, 4, 5, 6, 7 million. Okay. So now I'm graphing C of x. When x is 0, C is 100,000. And then when we manufacture 150, 20 times 150,000 plus 100,000. 3.1. So here's the cost function in green. Okay, so let's see again what we get with the revenue. Revenue when x is 0, y is 0. And I determined, I need to determine 450,000. I think I did that. 45, yes, I did. 6.7, yes, I did. 6.7, I'm going to say somewhere here. So this is R of x. Okay, last one. We want the profit. I'm going to use blue for the profit. So the profit when x is 0, there is no point. Let's see, when the profit is 0, 100,000 divided by 25. 4,000. So we had 20 here, so 4,000 somewhere here. Okay, and then when we plug in the revenue, in the profit, when I plugged in, I got 3.65 million. 3.65 right here. Oops, I missed it a little bit, sorry. So this is in blue, and that is the profit. Okay, we graphed all of them. You realize that I needed a lot of thinking to see how big the unit I choose on the x-axis, how big the unit I choose on the y-axis. And yes, we can graph all these three with a graphing calculator. Let's do just that. So I meant to clear that. I'm using the calculator with the stats students. Okay, good. So 20x plus 100,000. That's the cost. The revenue is 45x. And then we have 25x minus 100,000. We should make sure that I didn't put too many zeros. Now the viewing window from 0 to 150 is 0 to 150,000. With the scale, I put 20,000. Y minimum 0. Y maximum 7 million. Making sure that I have enough zeros. I do. And the scale 1 million. If you have this type of calculator, it will give you 3 different colors. Here's the first one, cost. Here's the second one, revenue. And here it is, the profit. So the cost was first, the revenue second, and the profit in blue. And I think it's here, I don't know what color is that, black. So blue, red, and black. Good. We still have 2 questions here. Any questions for me? Anyone? Is anyone paying attention? Anyone? I'm begging for a little bit of attention. Anyone? What profit or loss will the firm realize if the expected sale of 150,000, so the profit, so that's part D. We already determined that the revenue, what was it? I think I deleted it. Yes, I deleted it. So the profit of 150,000 will be 25 times 150,000 minus 100,000. And that was 3.6 something million, I think. 25 times 150,000 minus 100,000, which is, yes, 3.65. 3,650,000 dollars, of course. Okay, final question here. How many calculators must the firm sell in order to break even? So in part E, the break even point can be determined in two different ways: when the profit is 0, or not both, you don't need both. The revenue equals the total cost. So the break-even point, let's say 25x minus 100,000. That's how I determined that. We said equal to 0. I'm using this option. So x equals 400 units, or calculators. So the break-even point, however, break-even point is 4,000, comma, the revenue of 4,000. That's how we write the break-even point. So I look at the revenue, which is 45, and I multiply it by 4,000, and that is 180,000. So the revenue for the break-even point is 180,000.